Hello college algebra student. This video is for chapter 4.1 linear function. Linear function is used when the output y has a constant rate of change m with x. So y is the output, x is the input, and the rate of change of y versus x is a constant. So the format of a linear function is f of x equal to mx plus b. Do you notice that this look like the y-intercept form of a line equation? So because linear means a line, so it look like a line equation where m is the slope and b is the y-intercept. So we recall that anything that has x and y in the first power is a line. Right? 3x plus 7y equal 14 is a line. I can write this in a function format. So by writing y equal to mx plus b. So if I want to write this is an equation format. It's not in a function format. So if I want to write in the function format, I would write that like this. I would switch the 3x on the other side to isolate y on one side. So I would have 7y equal to negative 3x plus 14, and then I divide by 7. So we would have y equal to negative 3 over 7x, every single one divided by 7, plus 14 divided by 7 is 2. And so this is the y-intercept slope-intercept form, but the function format would be f of x. You replace the y by f of x equal to negative 3 over 7x plus 2. So this is a linear function format where m is the slope and 2 is the b y-intercept. And we say this is the function format. You can also see a function by not looking at a formula, but in a table. So for example, very often, instead of x, our input could be t, and our output could be a function, for example, d of t, distant maybe. So at t equal to 0, you have the output 7. At t equal to 1, you have output 10, etc., etc. So is this a linear function? Let's check if it's a linear. For linear function, we have a constant. Change of y over change of x is always the same number. So let's see in between, what's the change of y here? y2 minus y1 is 3, right? y2 minus y1, this one is also 3. From 10 to 3 is plus 3. y2 minus y1 is also plus 3. What about x2 minus x1? So from 1 minus 0 is 1. 1 to 2 is at 1. 2 to 3 is at 1. So all of the rate of change is, so I would say m between 0, 1 is 3 over 1. The rate of change between 1 to 2 is also 3 over 1. This is the change. This is the change. This is the change. The rate between 3 to 2 is also, I should do a close bracket actually, but it's okay. 3 over 1, so that they're the same. So if they have the same, then they are linear functions. So this is like this. So how can I find the equation or find the function represented by this table? Earlier we say m is 3, m is equal to 3, or you can just do 1, 10 minus 7 over 1 minus 0. So equal to 3. And then I have the y-intercept. When t equal to 0, y is 7. So b is 7 because that's the y-intercept. Or in this case, it's actually called the t-intercept. So my function would be d of t, maybe I'll just use d of t, is equal to mx or mt, 3t plus 7. Okay, mx plus b. You can also discover a linear function by looking at a graph. So if someone graph something like that, if you see a line, then it is linear. It's a linear function because linear means it's a graph of a line. So you don't have to find any rate of change. If you have a table, you have to check the rate of change. But if it's a line, graphically, you see that it's a constant rate of change. So maybe our interest in finding the equation of this graph. So we have, remember, the function should be f of x equal to, it is a d and an s. Mx plus b, right? So first of all, we want to find m first, which is the rate of change. For rate of change, it has to be change of y over change of x. So in this case, change of y. So I have 2 points. Let's say this point is 0, 250. And then I would have another point, maybe at 2, 400. So basically, you need to find 2 points on the grid. And so I have y2, m would be y2 minus y1, 400 minus 250 over x2 minus x1, 2 minus 0. So it's 150 over 2. So it's 75. So I have m. What is b? B is the y-intercept, which is 250. So the equation would be, I would use this distance. So we say d of, they don't say x, they say s. And they say this is d. So I would say d of s is equal to m is 75. Instead of x, I say s plus b. B is 250. And that's how you write the equation out. You basically find the rate of change and then find the y-intercept and you can write it out. How can I graph a linear function? Because a linear function is already written as y equal to mx plus b. We would just use the fact that you have slope and y-intercept. So slope is rise over run. B is the point of the first point on the y-axis. So basically, you will find b here because it's the y, right? And then you do rise over run to find another point and then graph it. Okay, so in general, that's how you graph. Just like when you graph a line. So graphing a linear function is just like graph a line. Some characteristic of a linear function. So if I have a linear function, what is something that I know? I know that it has a constant rate of change. It's called fb minus f of a over b minus a. It's primarily it's the AROC, but it's slope. There should be an x-intercept, which is where the graph cut the x-axis, and you find it by setting y equal to 0. X-intercept is also known as the 0 of the function, and then you solve for x. There should be a y-intercept, which is actually in the equation, so you set x equal to 0 and solve for y. Okay, so we'll do an example later, but for every linear function, you always want to find out slope, you always want to find out x-intercept and y-intercept. Now, what can we know about this function if we look at the slope? The slope actually tells us a lot about the function. So when the slope is 0, that means the function become f of x equal to b. It's a constant function. It is just a horizontal line. Okay, so when m is positive, then it's an increasing function. You would expect your graph, your line go like this. And if m is negative, then it's a decreasing function. Okay, if m is not 0, that means it's positive or negative, then you will have an x-intercept. But if m is 0, your x-intercept may not exist. Just imagine if you have a constant function that is y equal to 10, then this graph would never cut the x-axis, so you might not have 0. And what is the unit of m? Unit of m is slope, is the unit of y per unit of x. So it is a ray. Okay. So let's do some graphing. Or actually, let's do an example and analyzing a linear function. So see, I have a linear function f of x equal to half x minus 3. I know if it is written this way, this is m, and this minus 3 is b, right? So find the slope. The slope is m. So that is 1/2. The x-intercept is, then I need to find x-intercept. I have to solve it. X-intercept is when y is 0. So I would say 0 equal to 1/2 x minus 3. So I solve it by plus 3 on both sides. So 3 equal to 1/2 x. and then and then I times 2 on both sides. 6 is equal to x. So there is a x-intercept of 6, comma 0 is the x-intercept. Y-intercept? Y-intercept is already here, right? Y-intercept is when you plug in x equal to 0. So y is equal to 1/2 times 0 minus 3. So y equal to -3 is the y-intercept. So the point is 0, -3 is the y-intercept. And then sketch the graph. Oh, I don't have space here, so just do a really quick sketch. Y is -3, and then 1/2 is rise 1, run 2, like that. Okay. So I'm going to just stop here, and then do in the next video I will talk about how to this is about graphing, is about writing an equation and also some work problem. So I will have another video.